Welcome to solverfy.
42.92, we're told that high mass radionuclides can either decay that can either decay by alpha or beta emission belong to one of these four decay chains. This is 4n plus I, where this is either 0, 1, 2, or 3. Now we want to justify this statement and show that if a nuclide belongs to a particular one of these families, that all of its decay products belong to the same family. And then we want to classify a bunch of isotopes into one of these families. So, first of all, if it emits an alpha, then the change in its mass number is 4. And if it emits a beta, then it's unchanged. So we can see that since we go through a sequence of either not changing the mass number or changing it by 4, that if we have m decays, so we have 4n plus I, this undergoes m decays, then what we have left is, and each decay has to remove, each alpha decay has to remove 4 from the mass number. So just 4, m alpha decays changes it by 4m, and so we can see this is just a new n prime, and so it's in the same family. So now we want to classify all of these. Now, since they all have a 4n, I'm just going to write out what the value of I is, just for brevity. So for uranium-235, I is 3. For uranium-236, it's 0. Now, you can write 235 as 4n plus 3. So if you increase that by 1, you could write it as 4n plus 4, but then that's just the same thing as 4 times an n prime. And so the leftover bit goes to 0. For 238, now this is 2 greater than 236. And so you can save yourself a little bit of trouble from like actually trying to factor this into a form like that by realizing what the pattern is here. Similarly for plutonium-239, since all this is about the mass number, the actual element doesn't count. It's 3, and so now we go up to 240. We just did 3, so this has to be 0 because we've added 1 to 3 and sort of cycle around in a chain of these values here. So now for curium-245, we've gone up by 4, so that would take us back to 0, plus another 1 to get to the 5. So this is a 1. Curium-246, we've just gone up by 1, so it gives us a 2. For californium-249, we've gone up by 3, so that brings us back to 1. We started off at 2, go up 1, 2, 3, we're at 1. And for fermium-253, that's another 1 because that's just 4 greater than this, and we know if we go 4 steps in this sequence, we end up back at the number we started at.